Hello, today we're learning about one-to-one and onto functions. Okay, so I hope you enjoy this quick presentation. Okay, so we know what a function is from algebra. Well, nah, I guess you might not know what it formally is. I don't think it matters all that much, but this stuff is less obvious than what a function is. So a function is one-to-one if, let me just finish writing this out. This is a y right here, if you can't see that. So f of x equals f of y implies x equals y. Let me finish writing this. So, what this means is, well, this is a definition. So I'll give an example. So this function is not one-to-one because f of x over here equals f of y over here, but x does not equal y. So we have true implies false for this statement over here, meaning that this statement is false because something true cannot imply something that is false. So, but this function would be one-to-one f of x equals x. Because x equals x implies x equals x. So true implies true, meaning this would be true over here. So now we'll go over the definition of onto and then a few more examples. This one's a little bit easier. F of the domain, we'll call it A, equals the codomain. Okay, undo. How do you equals the codomain? So another example. Well, this function would be onto because if you for any element in the codomain, like here, you can find an element in the domain such that f of x equals y. But this function, for example, let's see. This wouldn't be onto because a point down here, there's nothing in the function that causes it to equal that. It wouldn't be one-to-one either because these 2 points have the same element in the domain that maps to that element in the codomain. Something that's onto but not one-to-one, you could have this, or I'll show it to you, I guess. I pulled this up. So you can see this is onto because for any element on the y-axis, you can find something on the x-axis that maps to it. But it's not one-to-one because the y is equal here, but the x's are not equal. Now, something that would be one-to-one but not onto. So you can see that this is not onto because for y down here, if y is -1, there's no x such that e to the x equals -1. Well, in the real numbers at least. But it is 1-to-1 because for distinct y, there will be distinct x's that map to it. That's pretty much the definition and some examples. And I hope this was informative. Have a good day.